I welcome you to the Introduction and Frequently Asked Question on Structure Equation Modeling Part 3. I am happy to have Professor Jitesh Thakkar, who is the author of the book on Structure Equation Modeling, Application for Research and Practice with Amos and R, with us for Introduction on Structure Equation Modeling. Professor Jitesh Thakkar is a Dean Academics and Professor Logistics and Supply Chain Management at Gati Shakti Vishwavidyalaya, Central University, Baroda. Dr. Thakkar was a faculty at IIT Kharagpur and has a professional experience of more than 25 years. He is a faculty expert at leading institute of IITs, IIM, and IITs and other. Dr. Thakkar is listed in the world ranking of 2% scientists by Stanford University. Let us continue in our discussion and evolve a great understanding on structure equation modeling. Let us begin with the first question. Sir, my question is, what is the difference between measurement model and structure model in structure equation modeling?
Yes, thank you, Archana, for raising an interesting and important question. And as we know, measurement model and structural model are the heart of structural equation modeling. And it is important to understand technically what these two models are and exactly what is the difference. And I would also like to share some example. So measurement model typically is a part of confirmatory factor analysis, CFA, and this part of SEM focuses on how well the observed variables, typically you have designed your questionnaire or survey instrument. So observed variables, items on a survey, measure the underlying latent constructs. So it assesses the validity and reliability of the scales used. When you look at the structural model, you have set of latent variables in your system. And typically, structural model or this part of SCM focuses on hypothesized relationships, that is paths between the latent constructs themselves. So you are trying to evolve a structure amongst the latent variables, and this model tests the theoretical connections among the unobserved, that is latent variables. If you look at the example, maybe let us say a typical case of employee engagement, maybe in an Indian IT firm, then if you are defining the measurement model, then it will test the items like I feel motivated at my work gives me a sense of purpose, I'm enthusiastic about my job, and all these basically are the latent constructs or the observed variables related to the latent construct employee engagement. Similarly, when you look at the structural model for the same context, employee engagement, then it would examine the hypothesized relationship amongst the leadership support, that is a latent variable. It can positively impact the employee engagement, that is again another latent variable, and which in turn positively impacts the job performance, that is another latent variable. So as I mentioned, structural model will try to examine the relationship among the various latent variables, hidden variables, unobserved variables, and measurement model will try to define the particular, validate the particular latent variable through set of observable variables or the constructs.
Professor Thakkar, that distinctly really helping us. Seeing this measurement model as a way to check in our research item, truly capture a concept, and the structure model as how the concept are connecting, making the structure equation modeling feelings much more approachable. Like in your example, you mentioned IT firm is linking a leadership support through the engagement to perform and bringing it to all into the focus cell. Begin with the next question. Sir, my question is, I'm confused about a goodness of regression and structure equation modeling analysis. Which one is better, sir?
Yes, I agree with you. And this question, many researchers or students, they ask. And even if you look at the domain of multivariate statistics, there are many techniques available. Let it be factor analysis, multivariate regression analysis, correspondence analysis, covariance analysis, principal component analysis. So many techniques are available, and it is quite an obvious question to understand that what is the difference and how SCM is more advantageous. So if you look at the basic nature of regression modeling, then it intends to define the relationship between multiple correlated observed independent that we call as predictor variables and one dependent variable called as observed variable. In comparison to the regression model, SCM has much wider capability to analyze the complex theories because it conducts the simultaneous regression and factor analysis, and because of this it has a much wider capability to analyze the complex relationships amongst the latent as well as observable variables. If you look at the typical advantages of SCM, then it accommodates multiple observed variables to measure the latent variable and builds a measurement model for each of your predictor, that is your dependent variable. It enables the analyst or researcher to control measurement error and get more precise estimate for the regression coefficient between the latent variables. Second, it permits the development of a model for testing complex theories, which as dependent variables acts as a predictor variables for other dependent variables. And typically, this characteristics allows the researcher to examine indirect effects and mediation structures. The third important aspect of structural equation modeling is that it is primarily used as confirmatory factor analysis and helps the researcher to translate a good theoretical model into a statistical model. If the pattern prevailing in the data set cannot explain the hypothesized relationship, because certainly through SCM you will try to test the hypothesized relationship for the sample or for the test data, and suppose your data is not really reflecting what your conceptual model has hypothesized, then the estimated parameters can be interpreted, and SCM will not represent the structure pattern prevailing in the data. And for this, you really need to modify your estimates. And for that, a different kind of procedure you need to follow.
Professor Thakkar, your comparison between regression highlights why the structure vacation modeling is so variable. While regression is examining one of the outcomes at the time, structure equation modeling allow us to analyze the multiple prediction, outcomes and letting factors, which is simultaneously. Empathizing is ability to address a measurement error, which indirect relation and valid theoretical structure which underlies its suitability for complex research questions. So begin with the next question. My question is, structure equation modeling analysis is involve a different kind of variables. Can you please provide me a simple, easy to understand the explanation of these variables, sir?
Yes, certainly. Let us try to understand what are those variables involved in my structural equation modeling analysis and how should I interpret these variables. So first is your exogenous variable. So these variables are not influenced by other variables in a model. For example, if we consider two factors that can impact the health of a person, such as food and exercise, we can see that as such, there is no relationship between these two variables. Yes, together they can impact the health, but I cannot say that food is linked with exercise and exercise. Okay, so they have separate impact on the health. and hence they are called exogenous variables in the model. The another variable is endogenous variables. So they are influenced by the other variables in a model. If we understand that food and exercise can impact the person's health, and hence person's health is considered as an endogenous variables in the model, because my health, person's health is impacted by food and exercise. The third important variable is manifest variable. This variable is a directly observed and measurable variable, also known as an indicator variable. So if we continue with the same example of food, exercise, and health, then food and exercise both can be measured in terms of appropriate units. So food, how many calories I have taken, exercise, how many calories I have burned. Okay, so that is always a way to quantify and measure. So you can measure it in terms of appropriate units, and hence are called manifest variables. In structural equation model, manifest variables are examined through path analysis. Now let's look at the fourth most important variable, and that is the latent variable. So latent name itself suggests that it is a hidden variable. It cannot be directly measured, but this can be measured through many other parameters or variables which are observable in nature. So the factors in a factor analysis are latent variables. For example, awareness on health. Okay, it's a kind of hidden variable. You cannot directly measure it. So if you want to investigate this latent variable awareness on health, then you can do the investigation in terms of its impact on health of a person. Then this can be indirectly assessed through a self-discipline adopted by a person and regularity of the food. So putting together food and exercise both have the impact. Putting together, it is an indirect measurement, and self-discipline is a latent variable. Latent variables broadly increases the complexity of a structural equation model, because a researcher or individual who is investigating the issue needs to take into account all the questionnaire items and measured responses that are used to quantify the latent variable. So this is about four important variables. One is exogenous variable, second is endogenous variable, third is the manifest variable, and fourth is your latent variable or unobserved variable.
The way you explained various types was exceptionally clear, sir. Calling up food and exercise are exogenous because they stand alone. And health is endogenous since it depends upon those factors which are really brings all the concept of life. Drawing out this difference between manifesting indicators like a survey items and latent construct like a discipline, and demonstrating both structure question modeling powers and thoughtfulness required in its steps. Sir, this is my last question I'm going to ask you. Sir, can you please explain me how structure equation modeling can be used for both confirmatory and exploratory research?
Certainly, as we are advancing in our journey, frequently asked questions on structural equation modeling. This is the third episode. And gradually, I am happy that you are asking some interesting questions, and that will certainly help our viewers to appreciate the concept of structural equation modeling, its value for varied applications in greater detail. So let me address your question. Can SEM be used for both confirmatory and exploratory research? So let us accept the fundamental behind SEM, and SEM is primarily a confirmatory technique. So this means you have predefined theoretical models which are available based on the literature, practical experience, triangulation of various literature insights, and these models we are trying to test for the given data set using SEM. But yes, it can have exploratory elements also. So when we look at the conformatory, the main use is to test whether the hypothesized relationship among variables based on theory are supported by the data. For example, if I go back to previous explanation and the example of food and exercise and its impact on the health, then there is a hypothesized relationship based on the previous studies that yes, health and food, they have the impact on the health. But just think about a situation that demography you are investigating, you are collecting the data from a sample, and this sample has some severe health issues because of genetic disorder. Now, this genetic disorder absolutely is altogether a different phenomena, different kind of effect, and you cannot really prove the hypothesized relationship in a confirmatory mode that food and exercise has an impact on individual's health because there are some other factors affecting. So here, the next stage comes is the exploratory, because now it's a new phenomena and I really have to explore it. So exploration through causation. Yes, I can use structural equation modeling for this new kind of situation also. And I would call now my SEM as exploratory structural equation modeling, which combines aspects of EFA, that is exploratory factor analysis, and CFA, that is confirmatory factor analysis. You can have the post hoc model modifications. Once you have, let us say, tested your model for a data, then you can apply certain modifications. So that is called post hoc model modifications. And you can utilize the modification indices for considering the causality among the various kind of variables. But I would like to caution my audience that this must have the cross validation on new data. So it's crucial to acknowledge that extensive post hoc modifications can lead to overfitting. What does it mean? I am overfitting my statistical model. You may get very good R-square value, fit indices are good, but maybe I have overspecified the relationship among the variables. I have deviated from the CFA, confirmatory factor analysis, and modified the relationship among variables extensively. And maybe my model can now show the better fit, but this overfitting itself could be a great problem, a flaw in the analysis. So it is important to acknowledge that extensive post hoc modifications can lead to overfitting. Let us see the example to make it more clear. Let's say market research firm wants to validate a new consumer behavior model. So again, you see the new context has come into play. So they want to validate a new consumer behavior model for online shopping in India, and they would use SCM in a confirmatory way to test their pre-existing hypothesis. Now, if the model doesn't fit well, they might use modification indices to explore potential new paths. Because whatever variables I have considered consumer behavior variables, now this hypothesized relationship in my model is not fitting well with the data. So what to do? Fine, I will look at the modification indices and then try to see that what are the new potential paths that I should consider. Now, after considering this hypothesized new paths, you test it with the fresh data. And this post hoc analysis is extremely important to see that my model is not overfitted, but it really represents the reality. So I hope this would help our viewer to understand the concept behind both kind of analysis, confirmatory structural equation modeling and exploratory structural equation modeling. Both CFA and EFA are combined when you have to investigate the new paths through exploratory structural equation modeling. Yes.
Professor Thakkar, I also appreciate your perspective on structural equation modeling, exploratory and confirmatory roles. It is assured to know that we can rely on structural equation modeling to test our theoretical model rigorously, while still allowing into room to explore new patterns throughout the exploratory research. Structural equation modeling is considered the post hoc adjustment. You're reminding us to validate any modification on separate data to set and ensure our findings remain robust. So now I'm concluding over here, sir. Professor Thakkar, thank you so much for your guiding us throughout this advanced topic on structure equation modeling. Through professionalism and clarity, you're refining our measurement instrument to mapping of completely networking of a relationship. You have occupied us with a practical roadmap for applying structure equation modeling. I'm looking forward to implementing this method and discussion further development and development together soon.
Thank you very much. And I expect that this interaction and the various critical questions in the domain of structural equation modeling we address would certainly benefit our viewers, and they would be able to appreciate the value, application, use of this technique, structural equation modeling, more rigorously. Thank you very much.